In this video, I will explain about introduction and problem statement. So first is introduction. In the world of warehousing, distribution and general material handling, a stacker is a machine that combines features of a walkie or walk behind pallet jack with features of a lift truck where an operator would typically sit or stand while driving, like a counterbalance, reach, or straddle lift truck. We are focusing on hand wheel stacker, which is a manual stacker, did not use motor to move the stacker or the hand of the stacker. There are few different designs that had already been used in the market with the different characteristics to complement the design. First, slim back design to occupy small spaces. Second, lightweight for easy handle. Third, big and strong for heavy duty load. To improve the already existed product in adding few more new characteristics with a new design in order to create a better and more functional product, they are easier to handle. This product is a hand winch handle that have two moving with which is the Y axis and the Z axis for easier handling. Problem statement. We have 4 problem statements. First, customer have to lift heavy objects from one place to another place one time per object. Second, putting objects on hard shelf is hard, especially heavy objects, and when it is done manually. Third, objects need to be pushed from the stacker to the shelf manually. And last problem statement is it hard to move the object on the fork hand from the stacker.
Next, I will present about the conceptual design for our hand wheel stacker. At first, we managed to design 3 different conceptual designs for the stacker. We used the Pew chart as the method to decide the best conceptual design that we will be using in this project. The conceptual design that we choose has both vertical and lateral movement controlled by the hand winch. The first figure shown is the datum used for our conceptual design decision, and the next figure is the final conceptual design chosen for this project. Next, I will present about the model of our product. This is the finished model of our product. The colored components is the main part of our product, which consists of the body frame, the wheel, the hand winch, and the forklift. The table shows the bill of material of our product. For the body frame, we use alloy steel as the material, as it is known for its strength and wear resistance. Hence, it is suitable for the body frame, as it is the most vital component which form the base of the product. For the wheel, we use cast iron for the material, as metal wheel is the best choice for heavy application. With metal wheel, the load capacities can be very high. Next is our hand winch. We use polished stainless steel for its material. And lastly is the most important part, which is the forklift. We use aluminium and a very tough steel as the material. It is used due to their toughness and its high tensile and yield strength, which is suitable for lifting the loads.
In the problem statement, there are also a need, which is the system or the stacker should provide lateral and vertical movement for loading and unloading load. So, in our system, we provide two types of movement, which is the lateral movement and the vertical movement. For the lateral movement, we use a rack and pinion mechanism. And for the vertical movement, we use the worm and gear mechanism as well as the bevel gear mechanism. To see how the product works, let's go to the next slide. This slide shows how our product works. For the lateral movement, we use rack and pinion mechanism to move the product forward. An output plate will position on the forklift to push the product and move by using pinion with the rack attached to the side of the plate. The roller between the forklift were assigned there to ease the forward movement of the product. For the vertical movement, we use the worm end gear mechanism as well as the bevel gear mechanism. By rotating the winch handle, it will produce the rotating movement of the worm end gear mechanism. This will lead to the rotation of the belting, which is connected to the shaft of the worm end gear to the bevel gear. The bevel gear will rotate the threaded rod, thus moving the threaded plate upward. The forklift that is connected to the threaded plate will move accordingly with the bevel gear rotation.
Last but not least, we are going to do analysis of compartment. In this process, I'm going to talk about two things, which is finite element analysis and optimization. In this part, I'm going to show the finite element analysis on one of the example that I choose, which is the forklift. And from this, we are going to open the simulation, and then we are going to choose static stress, and by that we are going to put a stress on the surface that we choose to see the amount of stress put on it. Before that, we are going to choose the material for the compartment. After we choose that, and we undergo the process of analysis, we are going to find the safety factor. The safety factor, which is to show like if we are choosing the right material for the compartment. After we can also see the stress, the amount of stress put on the surface that we choose. After we put force on it, we can also calculate strain and many more. Next, I'm going to talk about optimization on the next slide. For the optimization process, it's quite similar as the finite element analysis, but at this one we are going to calculate the load path on the object. In this part, I'm using another example, which is the output plate. After the process, we are going to see the load path of the force on the object. Based on that, we can see when the color goes to darker blue, that part doesn't have much force, much load acting on it. So that part can be cut out from the design to get the optimization of material that we can use. So that's why we use optimization to throw out the part that we are not going to use. In conclusion, we managed to solve the problem stated in the problem statement by creating a 3D model of a winch stacker that have the specification of below. First, in the problem statement, we stated that we cannot move multiple objects or heavy objects from one place to another at the same time. So by using the winch stacker, we can move multiple load at the same time with a maximum load of 500 kilo. Second, it has upward movement that can help moving heavy load on a higher place, which is this winch stacker have higher reach rather than using manual labor, which is they have a lower reach compared to the winch stacker. And the third one, it has lateral mechanism to ease the movement of load from winch stacker to the right without having to move forward, which is the person can use the pinion gear that have been created there, and then they just need to pull the handle, and then it will push the load from the stacker to the designated place manually without having you to push the product. So in conclusion, we can say that we managed to create a solution to our problem statement.